question here that's based on the reaction between hydrogen and nitrogen monoxide. So we're given the overall equation and we're told the rate equation, and we're going to use some concentrations of hydrogen and nitrogen monoxide and the initial rate to calculate a value for the rate constant and work out the units as well if there are any. We're then asked to predict what would happen to the initial rate if the following changes were carried out. So the concentration of hydrogen doubled, NO halved, and the concentrations of both reactants increased fourfold. We're then asked to explain what would happen to the rate of the reaction if the pressure was increased and what effect it would have on the rate constant. And then the final part of the question, we need to come up with a possible two-step mechanism for the overall reaction. So if you want to have a go at that, and then I'll go through the answers. To calculate the value for K, we need to rearrange the rate equation here to make K the subject of the equation, so it becomes K equals rate all over the concentration of hydrogen multiplied by the concentration of NO squared. And then we just plug in the values that we've been given. So there's the rate, there's the initial concentration of hydrogen, and the initial concentration of NO, but remember that needs to be squared. And hopefully you got the same answer as me, 8.3 times 10 to the 4. And you can see there the units. We've got effectively moles per decimeter cubed per second on the top, and we've got moles per decimeter cubed on the bottom. So you can see before I've cancelled, that's effectively moles cubed, dm to the minus 9, and then we cancel the moles, so that becomes moles to the power 2. The dm to the minus 3 goes off the top, and that becomes to the minus 6, and the seconds to the minus 1 stays. And so when we take everything up to the top, positive power first, dm6, mol minus 2, s minus 1. So if the concentration of hydrogen is doubled, the initial rate would double as well because it's first order with respect to hydrogen. If the concentration of NO is halved, the initial rate would quarter, and that's because a half to the power 2 is a quarter. And then if both of the concentrations are increased fourfold, we would have a fourfold increase from the hydrogen, but a 4 squared fold increase, so that's a 16-fold increase from the NO, and so effectively it would be 4 times 16, so it would be a 64-fold increase in the rate. Increase in pressure would increase the rate, and it's a straightforward collision theory explanation. Higher pressure means there are more particles per centimetre cubed or per unit volume, so there would be more frequent collisions per second, and I suppose to cover yourself you could always include with energy greater than or equal to the activation energy. What happens to the rate constant? Pressure does not affect the rate constant, it's only temperature that does, so nothing's going to happen. Two-step mechanism. You can see I've written the overall equation out at the bottom, and we know from the rate equation that 1 mole of hydrogen has to react with 2 moles of NO in the rate determinant step. So effectively our starting point is H2 plus 2NO makes question mark and question mark. So what do we need to make the overall equation? Well, we need 2 moles of hydrogen, 2 moles of NO. Well, we've got the two NOs in step 1. We've only got one hydrogen, so we're going to need another mole of hydrogen in at the start of step 2. So when we add these together, we'll get 2 moles of hydrogen. Products-wise, we need a mole of nitrogen and 2 moles of water. So the way I've done it is I've made a mole of water as a product in step 1. So that means to balance the equation, I'm going to need to make a mole of N2O. Now that doesn't feature at all in the overall equation, so I need to get rid of that, so it becomes a reactant in step 2. I'm going to bring in that other mole of hydrogen that I need to create my 2 moles of hydrogen, and I need to make another mole of water because I need to make 2 of them, and there's the N2 that I'm going to create as the product for my overall equation. And so when you add these two equations together, we get 2 H2s plus 2 NOs. The N2Os cancel, making H2O plus H2O, so 2 H2Os and an N2.